Hello everyone and welcome to the course Climate Hazards and Disaster Mitigation. So today's lecture, Hazards versus Disaster and Risk versus Vulnerability. I am your course instructor Priyank J. Sharma. So what we discussed last time, we explored what is the difference between weather and climate. So weather are usually short-term fluctuations in the essential variables like rainfall, temperature, etc. Where climate is a long-term fluctuation. So there is a very nice saying that is climate is what you expect and weather is what you get. So usually we expect that December it should be cooler, but sometimes December it is not cooler, it is warmer. So that is what it contradicts, that climate is usually the expectation but weather is what is the reality. We also discussed what the causes of climate change. One of the major causes is the carbon emission, that is greenhouse gas emissions, which is a much debated topic right now, and various industries like the transportation, the power industry, the manufacturing industry, and these various other industries are responsible for the climate change. We also understood what is climate variability, how it is different from climate change. So climate change is a systematic long-term change in the values of climate variable, but climate variability is a periodic change. So for example, if there is an ENSO is a 5-year period, so it has different cycles. It has El Nino, which is the positive cycle, and La Nina, which is a negative cycle. So it may translate from positive to negative over a period of time. So that is a cyclic phenomena. So climate variability usually depends on natural factors, such as the rotation of Earth, Sun and the Moon, because that is responsible for changes in seasons and even long-term variations. So these are the factors which we consider when we are talking about climate variability. So essentially it is told that if we do any analysis of climate variables, so the period should be long enough, let us say at least 20 years or at least 25 or 30 years, so that we can separate from climate variability and climate change effect. Otherwise, if we analyze just 10 years of data and if we say that this is due to climate change, we are drawing wrong inferences, because that can also be due to climate variability influences. So we saw that how ENSO, that is El Nino Southern Oscillation, which is one of the major factors affecting the global weather patterns, and there are other oscillations also which we discussed. And we also analyzed the climate vulnerability profile of India, where we saw that there are different regions exposed to single or multiple climate hazards. Like if we see the east and west coast, they are affected by cyclones. If we see the Indo-Gangetic plain, Brahmaputra plain and western plain of Narmada and Tapi in Gujarat, they are affected by floods. And if we see droughts, so there are regions like western Rajasthan, northern MP and parts of UP, that is Bundelkhand, parts of Maharashtra, Karnataka, which are affected by droughts. So this is how the climate vulnerability profile of India is shaped. So learning objectives for today's lecture, we'll understand the difference between hazards and disaster with suitable examples. We'll also study how risk and vulnerability contribute to turning hazards into disaster. We'll also explain the relationship between hazard, risk, vulnerability and disaster. And finally, we'll identify ways to reduce vulnerability and manage risks for disaster reduction. Coming to hazards. So hazard is a potential source of harm or damage. We already discussed this. So it can be natural like earthquakes, floods and wildfires, or it can be man-made, like there is chemical spillage or industrial accident or some transportation accident. Disasters, so a disaster is a serious disruption of functioning of any community or society that is caused by a hazard. Now disaster can result in widespread damage, that is financial damage, social damage, damage to life and economy as well. So both of these terms are very closely related, because a hazard, which we can call as an occurrence of an event, and disaster is its consequence. So hazard is perceived as a natural event that threatens both life and property, and disaster is a culmination of such hazard. So hazard is a potential for a disaster. So not all hazards translate into disaster, but if there is some exposure or vulnerable communities, so then your hazard can translate into a disaster. So for example, if hazard like cyclone hits an unpopulated area, say an unpopulated coast where it is totally deserted, it is not considered as disaster. But if that hazard damages significant life and property, then we can call it as a disaster. So summarizing it, hazard is an event that has a potential to cause injury or loss of life or damage to property or environment, while disaster is an event which occurs unexpectedly and disrupts normal functioning of that area, and that is what a disaster is. So if we see compare them side by side, so hazard is a potential, it poses a potential threat to life and property, but disaster is an event causing an actual threat to the life and property. So nature, hazard is potential for harm, while disaster is a realized destruction. Consequences, it is less critical while disaster is more critical. Time frame excuse me, time frame, hazard develops after a series of events which has occurred, and disaster happens very suddenly. This is very important. For example, for a hazard, let us say cyclone. So when there is a warming of ocean, then there is transport of soil moisture, then there is intensification, and there is a movement of cyclone. So there are a series of events or conditions which are linked. Now when that cyclone strikes the land, that is very sudden and imminent, and that is where the disaster take place. So the time frame is quite different. So that is why if a hazard is perceived, we can avoid it turning into a disaster. For example, if we know that a cyclone is progressing in this direction, so we can at least eliminate the people who are in that region. Of course, there will be economic damage to property, but loss of lives can be saved, and that is why the fatality of the disaster can be minimized. So now coming to next, there is risk versus vulnerability. Now what is risk? So risk is a very common term which we are very acquainted from starting. We all say there is some amount of risk in everything. So if we take a decision, like those who are investing in stock markets are more perceiving this term like financial risk. So the risk can be diverse. It can be financial risk, but here we are talking about more as a climate risk. So risk is generally defined as a probability of harmful consequences such as casualties, damage to property or damage to lives, disruption of economic activity or environmental degradation. So there is a probability of any harmful consequences, that is what we classify as a risk. On the other hand, vulnerability, it refers to the extent to which a community, structure, service or geographic area is likely to be damaged or disrupted by the impact of a particular hazard. So what is the extent to which a damage happens? So it can be damage to a structure, let us say a building is collapsed, or damage to a service. If you are not able to provide, let us say if some area is catching fire, a forest is catching fire, but your fire services cannot go, so its service or your water services are affected, or some geographical area is affected. So what is that disruption is caused by that particular hazard, so that extent we map it in vulnerability. So risk, it results from interaction between natural or human induced hazards and vulnerable conditions. So we require two things. We require your hazards as well as the vulnerable conditions, while vulnerability, it depends on the nature, construction and proximity to a hazardous terrain or disaster prone areas. So how communities are, like those living on the coast are more vulnerable to coastal floods or coastal erosion. Those who are living far inland are not vulnerable to that. So it depends what is the proximity to that particular hazardous terrain. Similarly, those who are living on mountains, they are more vulnerable to landslides compared to those living on the plains. So there are some key concepts in risk and vulnerability analysis. So first and foremost is risk, that is a possibility of loss, injury or death, which we call, and vulnerability, that is susceptible to damage or harm by a particular hazard. Exposure is very important. It is the duration or extent of a hazard. So how a particular community is exposed to that hazard, that is very important. Manageability, it is a capacity to respond to the needs created by the disaster. Adaptive capacity is the ability of system to adapt or adjust to the climate change. So if some disaster has happened, how the system can adapt to it, that is very important. And impact, it is a likely effect of climate change variable on a particular element. So what is the effect that is prominent or perceived, that is what we call impact. Risk has so many definitions, so we'll try to summarize a few of them, because each discipline uses risk in different contexts. So first, very generalized definition is expected loss of human property, disruption of economic activity due to a particular hazard. So risk is a combined impact of hazard as well as vulnerability. So it signifies the probability of harmful consequences or expected losses resulting from interaction between natural hazards and the vulnerable conditions. When we talk broadly in disaster management terminologies, so risk is the probability of hazard that will have a negative consequence at a given time and place. So time and place is very important. So at a given time and place, what is the consequences? Like flood is happening, so that area is getting flooded recurrently, but the effect of flood or the risk of the flood at time t or time t plus 1 or t plus 2 will be different depending upon the conditions. If we talk about other definitions, so it is known as a measure of probability and severity of adverse events to health, property and environment or things of value. So in different contexts, risk is defined in different terms, but when we talk about disaster management, we are mostly focusing on what is the negative consequences at given place and time, and that is what we understand. Coming to the risk triangle, so this is the risk triangle you can see, which is very generally used. So risk is a combination of three things. One is hazard, second is vulnerability, and third is exposure. So hazard, vulnerability and exposure. So when these three combine or they jointly interact, your risk level changes. So for example, let us say this is a triangle. Now for each region, these three parameters may differ. So if any of the sides of a triangle, let us say the sides of triangle changes, so what happens here? Your vulnerability has increased, so the area of triangle has increased, and ultimately your risk has increased. On the other hand, if we see your triangle being narrowed down, so that is your hazard, exposure and vulnerability, they are reducing, then your area, that also gets reduced, and your risk is again reducing. So these factors interact, what will be the risk level. So maybe a similar hazard having different vulnerable conditions and exposure can have different risk levels. So risk levels are to be evaluated based on these conditions, and they cannot be preconceived. So what turns a hazard into a disaster? So that is very important to understand, that not all hazards are disaster. So what are the ingredients that determine this? So disaster risk is not determined by the size or type of hazard or how many people are exposed, but not by this, but it is determined by how many people are exposed and what are the levels of vulnerability. For example, let us consider hazards. So hazards are like any physical changes in the weather event that turn extreme. It can be hurricane intensity. So what is the intensity? So hurricanes have different scales, like cyclonic storm we saw in the first lecture, super cyclonic storm. So there are different intensities. Earthquake, they have different magnitudes, so they are measured on Richter scale. So it can be, let us say, Richter scale 6.0. What is the heat wave severity? What is the precipitation extreme? If we talk about extreme, let us say 200 millimeter of rainfall occurred in a certain time. What is the period of drought? So these all things categorize your hazard. So what are the levels of hazard? Either it can be size or type of hazards that can be categorized by these things. Now coming to the vulnerability, whether a particular region. So vulnerability essentially determines what is the resilience of people in that particular region. So if you are using earthquake, now Japan is very famous for earthquakes, but still the losses in Japan are very less when you talk. Why? Because they have quake proof housing, so they are more resilient. If you are living in coastal areas, you are susceptible to more coastal floods, but if you create sea walls, you become more resilient. Again, if droughts are more imminent, you face a lot of water scarcity, like regions like Israel, but still they are very good in agriculture. Why? Because they have developed advanced agriculture techniques. So resilience is a very important criteria. So more resilient, the less vulnerable you are. So resilience you have to develop. Exposure, people in the path of hazard. So if an area is more densely populated, like cities like Mumbai, it is expected that the level of hazard, even though it is moderate, it will translate into higher risk because of higher exposure. So exposure is very high when you talk about Mumbai. In contrast, if you take a small city, any city, let us say it can be like Ujjain. So compared to Mumbai, the population density is very less. So the risk levels will be very less if the same type of hazard is perceived at both the locations. Next is early warning system. So if you have early warning systems in place, then you can evacuate people, and thereby you can reduce the exposure. For example, a cyclone is being projected to hit Gujarat coast. Now at the tentative location where the cyclone will hit, now you evacuate people. So by early warning system, you evacuate and you reduce the people which are in the path of that hazard, and you lower the exposure, and that lowers the risk as well. So these is a combination of all the things. So that is why it is very important to analyze three things in conjunction rather than analyzing them separately. Now we present a very interesting concept of risk matrix. Now what is a risk matrix? So a climate risk matrix is a tool to assess and visualize climate change risks by mapping the likelihood of a climate hazard against its potential consequences. So if we say likelihood, what is the possibility or probability of occurrence of a particular event? That is what we try to understand. And if we say the consequences, that is, we are trying to quantify their impacts. What are the impacts? That it may be moderate or it may be catastrophic. So that is what we, so for example, if the cyclone severity is very high, then the consequence can be catastrophic. If the severity is very low, it is just a tropical storm, it can be a minor or moderate consequences. So here you can see that based on in this matrix, the rows indicates the likelihood and the columns indicate the consequence. So we start with the lower levels, like it is very rare, unlikely, possible, likely, and almost certain. So this is the likelihood, and consequences, you have negligible, minor, moderate, major, and catastrophic. So this is the highest level. So when these two combine, let us say 5 here and 5 here, so when the likelihood of an event is almost certain and it is going to be very catastrophic, your risk is extreme. So the red indicates the highest level of risk, and as you come here where your event is rare and the consequence is minor, your risk is very low, and in between you have moderate. So this is how we can formulate a risk matrix where we can easily link the likelihood and consequences to the level of risk. So here we have perceived 4 different levels of risk. So extreme risk have the highest priority for immediate action. For example, if cyclone is striking a particular western coast, when we talk about India, so we have to identify the regions at more risk. For example, Mumbai is at more risk, then that should be given immediate action. If Surat is at least risk, it will be given next priority. So risk levels determine the priority. Again, regions facing high risk may require more detailed research and planning to determine treatment. Those which are under moderate risk, for example, regions which are very less prone to floods, so they do not require more interventions. So they may just require, design changes or changes in standards, and low risk, they just require routine maintenance. So based on the risk levels, whatever actions that are very closely linked. Now this is an example of risk matrix, so you can refer this link. From this we have just taken. So first we define consequence. What is the consequence? So based on this, whether it is insignificant or catastrophic, so what can be consequence? Let us say it can affect the infrastructure. So we take a particular hazard. Now whether that hazard can affect the infrastructure or not, that we want to see. So if it is not affecting, it is insignificant. Let us say its effect is just 10 to 20%, so minor disruption, so uska consequence is minor. If it is moderately disrupting that thing, so it requires repairing on a particular level, then it is moderate. If it requires so much repairing, then it is major, and if it is totally destroyed, it becomes catastrophic. Then for social, that is your healthcare systems or health employees, different levels are listed. Governance, so governance also, if it is a minor event, then you might require minor concerns, but if it is a major event, then you have to impose certain regulations. In sometimes, let us say if the cyclone is striking in some areas, the governance steps would be you impose emergency, so that people do not move outside and they stay indoors. So that kind of legislation are also there. What are the financial risk? What are the environmental and economic damage? So all these we define under consequences. So we try to quantify things so that we can link each of the levels to certain consequences. So this quantification is very important. Coming to likelihood. So what are the probability of damage that will define your likelihood? So the values are taken from two places. So this is the Australian standards and IPCC defined levels. So if anything which is having a probability of greater than 99%, then you say it is almost certain. 66 to 100% is likely, 33 to 66 possible, 0 to 33 unlikely, and less than 1% is very rare. So this very rare event, they have almost we can say they are rare but not impossible. They can still occur if there are very extreme conditions being favorable in that case. Now we took one hazard. So again, continuing that same example, so let us take rainfall. So there are different consequences, R1, R2, R3. So floods that result in damage to substations and indirect damage to overhead wires and underground pipes and cables. So you can see there is an infrastructure damage. So what is the consequence? Consequence is major. The event likelihood is likely. So what kind of risk you can have it? So if we go to our, then we can create our own matrix that if, as you saw, we have a risk matrix. So we can, align the columns that if it is likely and major, then you just put a tick on that. Then R2, you have seasonal average. So your risk becomes high in this case. Seasonal average rainfall changes can cause maintenance and repair issues to underground cables. So that is just maintenance and repair. So it is moderate consequence. Likelihood is possible. So your corresponding risk is moderate. And drought, that can reduce thermal buffering in underground cables and cause indirect damage. So again, this is moderate. Likelihood is possible. So you have a moderate risk. So based on that, your likelihood and risk, you can create a risk matrix. So for all these R1, R2, R3, T1, T2, F1, W1, we identify this risk level and create a matrix. So what the matrix would look like? It would look like this. So R1 was under major risk. So let's go back and check. Yes, the risk is high. So that we are following the same color coding. So it is major consequence and likely. So the risk is high. For R2 and R3, it is moderate consequence. It is possible. So risk is, moderate. And then there is nothing in low risk. There is nothing in extreme risk. Just high and moderate risk. So this is how your risk levels are determined. So when you are in the green zone, you represent low risk, yellow is little bit moderate, orange is high, and red is extreme risk. So for any given hazard, you can, or for a given region, you can analyze this and prepare this risk matrix. This is one more such example how to, you want to quantify it. Then how you can quantify? So you have consequences being listed here, you have the likelihood being listed here. So if any event is occurring 1 in 2 years, you say it is likely, 1 in 20 years it is rare. So that way we define it, and these are the levels. So let us take flood. So now this is a climate risk matrix for 2020 and 2050. So for 2020, if I want to quantify flood, so it is at this position, so where it is possible and it is major. So how we interpret this? So we multiply the likelihood and the consequence score. So what is the likelihood score here? So likelihood score is 3, consequence score is 4, so your flood, the risk score becomes 12. So in 2020s, your flood risk score becomes 12. Now this arrow shows it is transitioning into this particular matrix. So what is your consequence? It is still 4, but likelihood becomes 4. So 4 into 4, so your flood score is 16 for 2050. So that means your risk levels have increased when you talk about this. Similarly, if we take heat waves, what is the risk score? If we want to find, it is 4 into 3, 12 for 2020. Now it is becoming higher, 5 into 3, 15. So the risk score is increasing, and that is how we can, so for some the risk score is decreasing, for some it is increasing, and that is how you can analyze this risk matrix by quantifying this consequence and likelihood as well. Coming to vulnerability. Vulnerability is defined as the degree of loss resulting from potentially damaging phenomena. So what is the degree of loss which we have? So regions can be either classified as low or high vulnerable region depending upon their proximity or geographical and other factors. So vulnerability also signifies the reduced capacity of an individual to cope or recover from a hazardous event. So that means if you are more resilient, you will be very quick to recover from that event, but if you are less resilient, you will take a lot of time to recover from that event. The United Nations have also defined vulnerability as characteristics and circumstances of community, system or asset that make it susceptible to damaging effects of a hazard. So as I told, different agencies in different contexts define these terms. So in general, if I want to summarize it, vulnerability refers to increased susceptibility of people to be affected by disaster. More vulnerable means more susceptibility, less vulnerable means less susceptibility. So vulnerability is combining two ideas. One is the susceptibility and second is the capacity to recover from that event. So it is a function of susceptibility as well as resilience. So susceptibility has physical connotations and it is very easier to access. It is usually considered as proximity or exposure to hazard, where resilience is the capacity to adjust and recover when a system refers some external shock. Now we have three cases. Let us very clearly understand. So there is a person. So the house of a person is situated in a flood prone zone, so which is built not to withstand floods. So if there are imminent floods, that house is not withstanding it. However, the person has sufficient resources to rebuild the house if it gets damaged. So what is this? The first one defines the susceptibility. So there is susceptibility because it is prone to flood. Second is the resilience. He has that adaptive capacity that if the house is washed away, he can reconstruct it. So in such case, the person is susceptible but resilient. Coming to second, in case person in this other case, person has no house to relocate or no resources to rebuild. So in this case, what will happen? That he is susceptible, but the house is itself able to withstand the floods and it is not significantly affected. So in this case, the person is neither resilient and nor susceptible because that is not vulnerable. So the susceptibility is definitely low, and since it is not affected by that, so there is no question of resilience. And let us consider a person who does not have a flood proof house, nor he does have alternate resources, so that makes him more vulnerable, because he is not having a flood proof house, he does not have the resources to rebuild, and that is where he need to relocate. So in this case he had no resources, but he was less susceptible, so that is why he was less vulnerable. But here he does not have the resources and it is susceptible, so that is why the vulnerability is very high. So in context of disaster, vulnerability is a degree to which a system might react adversely to occurrence of a hazard. So that is what vulnerability is defined. There are different types of vulnerability, broadly 4 types: physical, social, economic and environmental vulnerability. Physical vulnerability, it is linked to individual assets or infrastructure arising from the physical components. So it can be divided into environmental and anthropogenic, like a person is residing in a landslide prone zone, or a person is residing in an earthquake zone with seismically unsafe construction. So any damage to the physical infrastructure, that comes under physical vulnerability. Social vulnerability is due to the social standing of a person. So he can be from some caste, some social groups, some communal relations, some political affiliation, different education, health, and like a person who are elderly person, they are more vulnerable to risk due to disaster, because in case of evacuation they are not able to run or faster, so that they are more vulnerable to these things. So that is the social vulnerability. Economic vulnerability depends on the economic status of the individual. So like if I have more money, I will be able to be more resilient, but if the money is less, my resilience is less, so that is why I will not be able to cope up with these impacts. And environmental vulnerability, it depends on the natural resource depletion or the resource degradation. Some risk examples: sea level rise risk. So that is a small island nation, they are at high hazards and high vulnerability, and they can be facing existential threats by 2100. Agriculture risk from droughts, because of changing patterns and combined with the farmer exposure and water scarcity, we have heightened levels of food insecurity. Again, due to more vector-borne diseases in warmer climates in particular, risk of malaria is more higher, because these underdeveloped countries, they have lower healthcare facilities, that is they are more vulnerable. Vulnerability examples like indigenous communities in the Arctic, so they are highly vulnerable to permafrost thawing, which because of warming temperature, there is ice melt, and they have very limited resources for reallocation. Urban poor, like in mega cities like Dhaka, so they are more susceptible to flooding because of climate amplified monsoons exacerbated by high level of population. Bangladesh is one of the most populous countries, and they have that is why they are more vulnerable to such kind of damages. And there are ecosystem vulnerability because of the acidification of ocean. So what are the key takeaways from this lecture? So we understood what is the difference between hazard and disaster. Hazard is a event which has potential, but that translates into some damage that becomes a disaster. Similarly, risk and vulnerability. So risk is a probability of occurrence, but vulnerability is a function of susceptibility and resilience. And if the susceptibility is low and the resilience is also high, then your vulnerability is also quantified in that particular manner. And lastly, we saw what are the different types of vulnerability and how they are translating into risk. So when we talk about risk, it is combination of hazard, vulnerability as well as exposure, and all these three things, they combine to form risk. So what is the activity suggestion for you? You prepare a list of hazards and disasters that happen in your region and their likely impact. So you can refer to any kind of news articles or published reports for more details. And this is the additional reference material. So we have provided some good reports for you to read over and gain knowledge. Thank you very much for your kind attention. We'll meet in the next lecture. Thank you.